Hello, and I want to welcome you to part 2 of simplifying radicals containing variables. These kind of variables are going to have a different look than the ones in the previous video. For example, if we look at number 1, simplifying this radical, we have the square root of 3. What you notice is that the square root of 2 worked out nicely. We could just pull the x out. With this, we have an index of 2, and if we were going to use that same rule of exponent over index, we get 1.5. Well, that's not very pretty, and we don't work with it, so we can't use that approach. So what we can say is that the square root of x to the third can be written as x to the second times x, because if you were to say it like x squared times x, remember we keep the same base, but we would add the two powers, giving us to the third. So we can actually pull this part out of the radical, leaving us with x square root of this power of 1, or just x. So we have x times the square root of x. Looking at number 2, we have x times, the square root of x to the 15th power. Now, an easy rule to work with these would be to, if it's odd, if the power is odd, simply break it to the number right below it, because it would be even, so we would have x to the 14th times x, because over here in our margin we'll say that if we had the x times 14, or x to the 14th power, times x to the first power, we keep our base, and we would have, adding those bases together, or x to the 15th power. So we can now use our rule of power over index gives us 7. So this can come out of the x of the radical as x to the 7th power times the radical of x. Looking at number 3, let's first have 4 come out of the radical as 2, and then we can think of the x to the 5th power as x to the 4th times x to the 1st. We can use our, even when it's even, we can use our rule of power over index, or just 2. So that means we can pull our variable out with the power of 2, leaving in the radical the x to the first power, or just x. With example 4, we see that 65 is actually not able to break down into a nice number right away, because it is only divisible by 1 in itself and 5 and 13. And 5 and 13 are prime along with 1, so this cannot be broken down to any perfect squares. So we know for certain that 65 will be broken down and left in the radical. And how about x to the 12th? Well, remember, since it's even, we can take our power, divide it by the index of 2, and leave it as 6. So we can actually use 6 as our power and pull it outside of the radical as x to the 6th times the radical of 65. Looking at number 5, what I would first recommend is taking this and breaking it into 2 separate pieces. So instead of the radical of 20 over m to the 10th power, I'd say radical 20 over the radical of m to the 10th. On top, we've worked this before, that 20 is the product of 4 and 5, and note that 4 is a perfect square of 2, so we can pull 2 out and leave 5 under the radical. Now with the 10 here in the exponent, it's an even number, we can take our power divisible by the index, leaves us as 5. So we can actually pull x to the 5th power out of the radical. And there will be no radical because nothing's left to work with. So we can just carry it along, and this is our final answer of 2 square root of 5 all over x to the 5th power. Looking at number 6, let's break this down as we did before. Instead of having the square root of 25x over y to the 14th power, let's break it into square root of 25 times the square root of x on top, and on the bottom, square root of y over 14. When we simplify, we see that 25 is actually a perfect square. It'll be brought out as 5. We're going to be left with that radical x on top. And on the bottom, since 14, the power, is even, we can divide it by 2, which is the index, and get 7. So we know we can pull y with the power of 7 out of the radical. And that is the answer. If we were to look at higher roots, at simplifying higher roots besides ones that contain just a power index of 2, we have a 3 here. So we have 3 square root of 48. What you want to do is try to break this into things that have square roots. And you can think of that having 48 with the product of 8 and 6. And as you know, 8 is actually a cube root of 2. So there's our cube root. 8 come out as 2. Because 2 times 2 times 2 is 8. But we cannot break 6 down any farther. So 2 cube root of 6 is the answer. With this second example, we have the cube root of 192 over 8. What I would recommend is breaking that down into the problem cube root of 192 over the cube root of 8. And the cube root of 192, we can break that into the cube root of, how about 64 times 3. 64 is actually a cube root of 4. So we can actually pull 4 out, cube root, and we're going to be left with the 3 inside. On the bottom, the cube root of 8 is 2. So we can just pull out a 2. And this can actually be simplified. 4 cube root of 3 over 2 can be simplified as 4 over 2 is just 2 cube root of 3.